Welcome to study this UNIPS module related to conceptual change in learning of life sciences. After studying this module, you have competencies to 1. Understand the role of prior knowledge and conceptual change in learning. 2. Activate and take into account students' prior knowledge in your own teaching. And 3. Recognize students' typical misconceptions related to your own discipline, and you know how to get students to weigh their prior conceptions with the scientific model. Conceptual change refers to learning process in which one's existing knowledge structures related to certain concept change fundamentally. The term conceptual change refers to the idea that learning is not only about acquiring new information and piling fact upon fact, but about recognizing that existing knowledge structures often need profound changes. The concept was first introduced by Thomas Kuhn to indicate that the meanings of concept embedded in a scientific theory change when the theory changes. Thus, the role of prior knowledge is crucial in learning. Next, let's dive deeper into this. According to constructivism, knowledge cannot be transmitted, for example, from a teacher to students, but learning requires that a learner actively builds meanings for new knowledge and makes connections between old and new knowledge by processing new information. Now, consider this last sentence for a while. When studying the content of this module, also, you should actively process new information and consider the relevance of this information for your personal life as a teacher and also as a learner. Okay, let's continue. In processing new information, prior knowledge has a crucial but dual role. It can either promote or hinder learning. Prior knowledge that is in unison with the new knowledge to be learned typically supports learning, whereas prior conceptions that are in conflict with the new knowledge can hinder or even prevent learning because changes in one's knowledge structures, meaning conceptual change, is needed. Nowadays, there are lots of research in life sciences and also in other disciplines that also university students come to lessons loaded with lots of prior conceptions, part of which are not in harmony with current scientific understanding. This is particularly typical for scientific concepts that often cannot be learned via observations, but learning of which requires systematic and intentional teaching and studying. For example, a typical misconception related to the nourishment supply of plants is that plants would get chemical energy for growing from outside, just like animals do when they eat. Typically, it requires conceptual change to understand that actually plants produce their nourishment by themselves in a process called photosynthesis. You may figure out several other examples related to your own discipline. In order for these misconceptions to be revised, a conceptual change is needed. In conceptual change process, one's previous knowledge structures sometimes need profound changes. One may need to abandon certain previous conceptions. In order to successfully build new knowledge and reach deeper understanding related to topic at hand. This results in that reaching of conceptual change is everything but easy for the learner. Why is it difficult to change one's previous conceptions and reach conceptual change? The challenge related to reaching of conceptual change is that typically misconceptions 1. Provide enough explanatory power in everyday life. One doesn't notice or experience true need to revise one's previous knowledge structures. 2. Misconceptions typically are developed during a long time and hence are tenacious and sometimes extremely hard to be changed. This is particularly typical when studying scientific concepts because, like said, characteristic for scientific concepts is that they are somewhat counterintuitive and in conflict with everyday knowledge. Additionally, learning of scientific concepts often requires understanding that a familiar word may have an unfamiliar meaning in a new context, which is likely to be problematic. Next, we will learn how a teacher can promote conceptual change via instruction. And for this, we need to understand the prerequisites for conceptual change to be reached. If you already have read the provided article of Posner and his colleagues, you have learned that there are certain prerequisites for conceptual change. At first, conceptual change suggests that one notices the discrepancies between one's previous conceptions and the scientific explanation and is able to weigh them critically. This so-called metaconceptual awareness is usually a prerequisite for conceptual change because it induces dissatisfaction with one's previous inaccurate conceptions. In addition, conceptual change suggests new information to be 1. Intelligible, meaning sufficiently clear, 2. Plausible, meaning reasonably true, and 3. Fruitful, meaning potentially productive. In other words, students must be convinced that new concept offers them more explanatory power than their existing concept affords. This explains why conceptual change is nearly impossible to achieve without intentional and systematic studying and teaching. Now that we have better understanding about what it requires for students to be able to reach conceptual change, we can design a variety of instructional methods to support students' conceptual change. It is important to note here that the process of conceptual change usually requires various changes of perspectives to open up a whole new conceptual space, and this usually takes time and effort. Hence, the learning environment needs to support conceptual change using various strategies to facilitate students' high-level learning. All in all, the most important thing is to activate students to become aware of their prior conceptions and weigh them critically against the scientific explanation. This can be done, for example, by utilizing different kinds of pretests or pre-tasks. It is a good idea to activate students' metaconceptual awareness via discussions, which provide opportunities for them to become aware of their own conceptions and potential misconceptions, as well as other students' conceptions. Sometimes you may want to offer possibilities for the students to test their previous conceptions, utilizing, for example, inquiry-based learning activities, which provides them concrete opportunities to make notions about the usability of them. Thus, the main message is that you may choose whatever meaningful method as long as it promotes students to critically evaluate their existing knowledge structures and supports them to reach conceptual change. Now that you have studied the content of this video, you may have made a notion that designing of effective science learning environments necessitates several skills from the teacher. First, the teacher needs to have a solid domain-specific understanding, and second, an understanding of the challenges associated with science learning in general. So, make sure that you have reached learning outcomes of this module and that you understand that. 1. Prior knowledge has crucial but dual role in learning. 2. Learning of scientific concepts often requires profound changes in one's prior knowledge, that is conceptual change. 3. Conceptual change typically requires intentional studying and instruction. 4. Teacher can facilitate students' conceptual change by providing opportunities to weigh prior knowledge with the scientific model. Thank you for watching this video. Now it's your task as a teacher and as a learner to bring these things into the daily practice in your classroom.